my permission. Can you believe it?
Oh, that's so adorable.
Well, I don't know if that's cool. It's like weird. She's too old to be in this, problems
Yeah.
or
But
situations.
I still think like that's just a beautiful thing though that she asked you.
Oh,
You know.
oh no, she have to. I mean, I am the boss. Just kidding.
Yes, you're the boss over your mom. From the time you were born, you were like, we're doing it my way. No options. Okay, did Isaac say he was going to be able to make it today?
Oh, there you go.
Hello, everyone.
Oh, he's there.
Literally, well, I remember there was a time that he had said he couldn't come to one of these. And I couldn't remember if that was like a past time or if that was like a future time. He's like, I can't make it. So I literally, Isaac was just asking like if you were coming and or if this was one of those ones that you missed and you literally logged in right then.
No problem. I'm here.
Hey. All right. So, goodness gracious. Okay, so did everyone do the prep?
Yes. Well, I did. I don't know
Okay.
about anyone.
Well, excepting Estrella, because we
No,
know that,
I just
yeah.
read to the lesson because I usually what I do is I read and I see all the videos and then I go through the things and try to see if there is something that I need to go over again.
No, you're good.
That's my way.
You do it however you want.
Yeah.
I just know, for me personally, I got tripped up on a few questions, and I was wondering if it was okay if we went over those super quick.
Yeah, that's fine.
Okay.
Yes. I'm still working on the application actually. I did work a little bit on the quiz, honestly. But on the application, I'm still working on. So it'll be helpful for me as well.
Okay. Because I know I've just got, let's see, is it 2 or 3? Yeah, it's 3. Okay, so the first one was they're all in part 2, first of all. So question 6 is, a sample size of n equals 4 is taken from the normally distributed, you know what, why am I doing this? Let me screen share. Can't believe I almost ignored my time-honored tradition of screen sharing. Screenception! Okay. So, number 6, a sample size of n equals 4 is taken from the normally distributed 2011 sales data. What is the probability that the observed mean of x is less than 40? And so, our information...
I think because of the video, so you take the one that is usually the and then you take out the one that they wanted to do, and then oh my goodness, it's so like I'm trying to. I have to read the problem. See, that's something that you cannot do if you are gonna do the math meeting.
Seriously.
Okay, let me go find this.
Okay. And then, so yeah, these are the answers for those. It says about 16% using the 68, 95, 99.7 rule. But that doesn't make sense. Because if I'm using that rule, 68 plus 16 is not 100. 95 plus 16 is definitely not 100. So that makes 99.7 not.
Okay, let me pull that out this quickly and see if I see it from another perspective.
Oh, you're pulling up that video?
No, I just I don't think we need the video from this one.
What question is that?
It is question. Goodness gracious.
Question 6.
Question 6 in part 2.
Okay.
Okay, so can you guys see my screen now?
Yeah.
Yes.
Okay, could you before?
Yeah.
Oh, okay. 'Cause it said, "Do you want to present this to everyone?" It was like, what? Have I not
Okay.
been doing that?
Okay. Repeat me again. What was the problem that you were?
It's part 2 of question 6, and
Okay.
part 2, question 6. A sample size of n equals 4 is taken from the normally distributed 2011 sales data. What is the probability that the observed x is less than 40? And x, that kind of x is the mean, right?
So in the top you have the real problem, and it says that you have a probability of 45. So, but this one is asking you to take, I mean, like they say, what the probability is to be minus 40. So you have to take away.
Okay, say that again. So what minus 40?
45 minus 40. Do you remember that?
Oh, so 40 is the number we're supposed to plug in.
Yeah. So because they are saying, okay, so you are doing this problem in the top, but I want you to change this information and give me this result. So but I let me see if I can find the the formula that was using the professor. Let me see.
Was it the
The
z
one?
equal?
X minus u
Yeah.
over standard deviation?
Yes.
That
Over
one.
the
I don't
square
know.
root of n.
Was it
And I don't
standard?
know.
Was it square root? Or was it regular?
That's the thing that I wanted to know, if we have to use that one or the other.
I
Yeah, it
think
doesn't
it's
look
the
like
one
this one. I
square
just
root.
tried it the one way. If y'all see my screen, I just
Okay.
tried it the original way. So
Okay.
45 minus 40, enter, is 5 divided by 10.5. And that's not the answer.
Okay.
I
Can
looked
you
up
use?
the video, and he's using the other formula.
He's using
The
that
one
45 minus 40 divided by square root of 10.
divided by the standard
by
deviation
0.5,
divided by.
and then
Square
you
root.
have to divide it again for the square of the
Oh, it's that one formula. Dang it, I can't access my notes.
Hey, that's a great picture. That's you?
Thanks. Yeah, that's me from like my junior year of high school.
Oh.
Yeah, we were supposed to put a picture, and I was like, you know what? I look okay in this one. No, I'm kidding. So, okay. And so the formula was the one that was
It's the one with the
x
square
minus
on the
u
bottom.
divided by standard deviation over the square root of what?
Yeah, of I think it's
Was it x or the standard deviation?
I think it's a standard deviation. Let me look it up quickly. I'm
No
trying
worries.
to find it, but okay, let me see. I think that this one is. Let's look it up for a little bit. I think it's in the. Oh my goodness, it was so that long. Let me see.
Wouldn't it be the sample size? The square root
Oh
of
yeah,
the
there we go. It's right here on my screen, y'all. Yeah, so x minus u. Oh, so I was doing it wrong too. 40 minus 45. We have negative 5 for the 1. So negative 5, remember that. And then square root of n, which is... What's n, then?
Wouldn't it be
the sample
4?
size?
I mean, it's question 6, right?
Oh yeah, sample size of 4. Thank you.
Yeah.
I was instantly worried. So 2. And so then it's standard deviation 10 divided by 2. Enter. This already isn't looking like it's ending well. So we have negative 5 divided by 5.
Yep, that's right.
What? Oh, right. And then we plug it into the probability applet, right?
Yeah, and then it will give
Mm-hmm.
you the percent. I mean, like the 0 point
The
something
area.
or whatever.
Okay. So 1, 1. And then less than 40% is that one. Okay.
Yes.
And you don't take the other one. So what is the result in the very top of the apple?
I am not the father. Wait. Oh, wait. We weren't
So
able to put that.
you write the number that you get on this one
Yeah.
that says 6 score. Did you get
Yeah.
it?
Area is 0.1587, and looking over here, it says about 16% or 0.1587 to be exact. So
Okay, so we made it. Huh.
we got that one. Cool. That's gone.
Another
And then
question.
sample size of n. And so this is the exact same thing. Number 9 is.
Let me look it up.
Well, it looks the same because it's questioned the same, just with different numbers.
Okay, so if you put it
Yes.
on the calculator, it will give you exactly the same.
Yeah. So calc.
Well, not
Because if we
the same.
look, so 50 minus 45, that gives us 5. So we got to remember that number, 5, and then it's square root of 25, which is 5. 10 divided by 5 is 2.
What the heck?
That's the bottom half, and then it's 5 divided by 2.
2.5.
And then we go over to our applet, and we type in 2.5, and it says over 50, which is 0.0062 to be exact. I hate myself.
There
Oh,
it is.
nope, we're good. There we go. I thought it was number 7, and I was like, how did I get this wrong? And I was crying on the inside.
Oh,
Okay, there we go. And then number 10, it says 15. Mine's just numbered weird because I put them all in here like this. And so that's 0.62, something like that. Number 10 is, and this is I think where I was confused, because it's the sample size of n equals 36 is taken from the right skewed 2010. So it's the probability that the observed x is between 37.5 and 42.5. Can we still put that on the normal probability graph? Because I don't think so, because if it's right skewed, the percentages won't be correct. Right?
Well, I
don't
didn't
know
get the
that.
chance to go over this one, but just remember that in this class we are doing normal distributed and that whatever is not normal. And I don't know, maybe it's from that. Let me
Here.
see.
For entertainment purposes, let's do it like we do everything else and see what we get. Holy crap, I can have multiple calculators open at once. Why did I close that one then? Give me a second one. I want all the calculators. Okay, so, and this is new data too. There we go.
Mm-hmm.
So, one calculator, clear U, and 2010x. Oh wait, that's not as high. Oh no. Oh yeah, there it is. So what we're looking at is the n, which was 35, right?
And it's 4.
Oh, 36.
Huh?
What is the that 10 that you are looking at?
It's question 15.
Oh, 15. Okay.
Yeah.
Okay.
Oh, I thought you were still looking at question 10. That's why I was like,
Kelsey, what are you doing? No.
Yeah, you
Question
have
15.
a sample size of 36.
So 36 minus 40 is our -4. Keep that in mind. And then doing the same thing is square root of our number, which is 36, which is 6. And so that's 12 divided by 6 is 2. Right? Yeah, it's 2.
mm-hmm.
So we have -4 over 2, which is -2. But the problem is how do we figure out what the probability is? Like, that's my worry, is I guess we could go like -2, see what happens. -2, enter. And so the question was asking
It's
between 30.
What is the probability that the observed is between 37.5 and 42.5? I think that you have to take those numbers in.
You think I have to type them in individually?
I don't know.
Caitlin, what did you do for this one? Because as obvious as we just tried on the normal graph, like I thought it wasn't going to work.
Did you see the video from the one that he solved all the problems?
I did not. I usually don't try to watch that one unless I need help. That way I'm not like getting reliant
look at you.
on. I'm a stubborn person. Caitlin, I don't know if Caitlin remembers me from high school, but if she does, she can attest to that.
You're a band kid. Of course, no, just kidding.
I'm a French horn. Of all the people that are stubborn, it's us because we just want to be heard.
Aw. So, wouldn't we use for the probability, the 68, 97, 99 rule?
I thought we would. Oh. But look at this.
That's how I did it.
Well, because look at this. She's right.
So yeah, so you use.
Is it somehow we need to get the probability for each number and subtract
and then,
it from one?
So it's just easy. See, that's what I hate about math.
I hate everything about math.
Okay.
Okay.
So we need to pull up notes about probability then, and like how we solve for probability without our friendly neighborhood graph. Z-score.
Wait, what? Yeah, this is 15.
It's you don't have to use the same one that we used before, but with every number. That's not what we are doing now.
The what?
Oh no, we are trying to find probability.
Yeah, for something that's right skewed. If it was just whatever,
we're gonna use. Oh, sorry.
What?
We're gonna use the same formula.
Okay, so we use the same formula, but the problem is now we got -2. What do we do with that? Because we can't put it in here because it's right skewed. Ignore me like clicking on everything. Yeah, and so that's what I'm worried about. Is I'm worried that one of these is going to pop up on the quiz, and we're going to get stuck.
I went in and they don't. It doesn't.
They don't have any of this horrid heaven on earth.
That solve all the problems, at least that they asked it in the exam, and then we are screwed.
Seriously, because yeah, I just want to figure out that one because like right skewed. Because like I do get the adding up, but the question is how do we add it? How do we get the probability from 37.5? Oh my dear heavens!
What the heck?
I may have just figured it out, but no, never mind. I didn't. Because I was like, oh, maybe Omni calculator. Omni. But then I remembered this thing doesn't show probability. It just helps you figure out the z-score. Because I was like, if we plug this all in, we'll get the no, Kelsey.
But
no.
if we can find a way to take the formula of the probability with the one for the z-score, like because did we have the z-score?
We did, but or I guess we didn't have the z-score, did we?
So what I understand, because I went back and saw the video to see what he did, is he did the formula for both the numbers and then subtracted those numbers and used that on the probability applet.
Oh.
Oh yeah, and it have totally sense because if we have to find the probability, we don't need that number to get into to using the formula. Actually, we get the probability after the apple thing. Oh my goodness.
Okay.
I'm so
what
today.
You're good. So what you're saying is instead of using n equals 36, we should be using 37.5 and 42.5.
No. The 37.5 and 42.5 would be the x. And
to plug into z-score. Right?
Well, it's not that formula. This one is where it's the standard deviation divided by the square root of n.
Okay. And so would this be n? 37.5 be n?
No,
or would
n
it be
would
the
be
x?
36.
Okay. So
37.5 would be the X.
alrighty. So then we have 37.5. And what was the mean? Does anyone remember?
40.
40?
One in the top, yeah.
Okay, 40. So then we have, that was the wrong one. Go back to the other one. 37.5 minus 40, enter is negative 2.5. Okay, and then square root of n, which is 36. 6, and then 12 divided by 6 is 2. And so divide by 2, negative 1.25.
Yep. And then you do the exact same thing with 42.5.
Okay,
And then
so
you
we have
subtract the numbers you get from both.
42.5 minus, we said 40 is
Yes.
2.5. So you just remembered 1.25. And then 2. Oh my goodness, why did I even try to do that? 2. So let's go. Equals. But then we have a, so it'd be 1 minus 1.25 minus negative 1.25. I mean, that's not right. Because it'd be 1 minus 1.25 plus negative 1.25. And that brings us right back up to 1. Because it shows the probability in the answers as being the same. So either way, the number would be the same. 0.1056. And it shows we check those from 1 to get 0.7787.
Okay, so I have the formula used right here. The one
Okay.
that the professor used for that one.
Mm-hmm.
And Guy, can you please? Okay, nice, thank you. Okay, so he said that he used the formula for the Z score, and then he used a 37.5. That is the one that we are using, and then that one is minus 40, and then he divides for 12, and then divide all that for the square of 36. So did you get that in the calculator?
Yeah, we got these x minus the mean over.
But with these numbers that I'm telling you,
Repeat the numbers again.
37.5 minus 40 divided by 12, and that is divided again for the square of 36.
Yeah, I did that because see, I did 37.5 minus 40, enter, negative 2.5. I left that alone. Square root of 36 is 6 off the top of my head. Standard deviation was 12, right? Yeah.
Yeah.
So 12 divided by 6 is 2. So then you get negative 2.5 divided by 2, you get negative 1.25. And then
when you put that in the Apple
Applet?
thing,
oh, we can use the applet for that, even though it's right skewed?
You want to know the probability, and the only way to know the probability is using that one. I mean, at least for this class. I don't know if you can get it for another way, but they give us that, and then you put it on the graph, in the bottom right there. You put minus 1.25, and then at the top
okay.
you will see the
right.
probability.
Right skewed.
Hello?
Oh, but except, Caitlin, if you look at my screen, it's right.
Oh, yeah.
Which makes sense, because you're not looking for how skewed it is. You're just looking for the probability, and normal or not,
Yeah.
I guess that's correct, because it all adds up to 1 still.
Mm-hmm.
Okay, and then, of course, you look at that. That's both of them, and you minus that by 1, and you get the answer. Okay, that makes sense. Are we all good there?
Yeah.
Okay, feel less crazy. That being said, it's time for our favorite screen sharing, where we never see Kelsey's face. Ever. Let's go. Might as well go here. There we go. All right, everyone have their quiz up and ready?
Yep.
Yeah.
Yes.
Okay. And as the usual, you know the first two questions. Answer on your own accord. Answer C. Oh, answer C.
Okay, does anyone may have all the answers, like those that we have to use the calculator?
I have all the answers.
Okay.
Oh my goodness. So we'll use you as a fact check, right, Isaac?
Go for it, yes.
Okay, cool. So what I want to do is then if Isaac knows all the answers from the quiz already, I want us to try to go through it and solve it together, and then we'll turn to Isaac. And if we're correct, cool, we'll move on. If not, Isaac can give us the answer and we can try to figure it out. Cool?
Yes.
Okay.
All right. So question 3. Use the normal probability applet to find the combined area under the standard normal curve that is to the right of z equals 1.358 and left. So what that's asking is 1.358. It's asking for that, I would assume.
Yeah, I think so.
Because it asks
Give me
to
a
the
second.
left
Let me
of...
just log to the right group meeting quiz because I'm on the wrong one right now.
Oh.
So I can check the answers.
Oh, okay.
Okay. Did you wanted us to wait before we said our answer?
No, you guys can continue if you'd like.
Oh, okay. So the answer
Yeah.
we get for that, just looking at this probability, is 0.1745.
Did you okay? 1.745?
0.1745.
That's what I got.
Because it's asking
0.1745. So it says
That is
that we
correct.
have to round it to the 3 decimals.
so 175.
175.
Isaac?
175.
So the answer is 0.175.
Got it. Okay. Question 4. Which of the following have a smaller standard deviation if 9 observations are randomly drawn from X? The distribution of the individual observations X or distribution of the sample means X? Goodness gracious. Because I remember reading a rule, like the large numbers is the closer the number, like the larger the individual observations get, the closer they get to the standard mean. But does that mean that the sample means then would have a smaller deviation?
Let me check.
I don't know. Part of me says like this cannot be determined from the information given. Because I mean like 9 observations could be high for the sample means. The sample mean could be like 2. Or the sample mean could be 100 and 9's not enough. I've purposely been unplugging it all night.
I know you haven't.
I'm so shooketh I need to mute myself. Okay. So I don't know. What do you guys think, Caitlin and Estrella? Do you think we can get an answer from this? Or do you think it's a cannot be determined?
I think that I am reading just quickly here. And I will
You're
give
good.
you
I
the
just
answer
love that
in about-
response. I'm thinking I am reading.
I'm not sure.
Isaac, is one of the answers correct on those 3 options? No. Well, okay.
I'm trying to
I read the answer in one of the lessons, and so I'm trying to you can find that out so I can.
You're good, because I know it's not in lesson 7. Because like half of lesson 7 was just reviewing.
I think it should be the distribution of the samples means.
You think so?
Yeah.
Okay. Are we in agreement on that? Because that was my initial guess, but then at the same time, I started debating. But that would make sense to me, is that the means would have a smaller deviation.
From what I'm looking at, that sounds right.
Okay. Isaac?
The distribution. Give me a second. The distribution of the sample means X. Yes, that's correct.
Yes! Thank you, Estrella!
Haha.
Alrighty. Which of the following results implies that the spread of X decreases as the sample size increases? We literally were just talking about that. The law of large numbers. Right?
Yeah.
Okay.
Yep.
Isaac?
That's right.
Use the following information to answer the next 4 questions. Scores on the quantitative portion of the GRE are approximately normally distributed with the mean 150.8 and the standard deviation of 0.88. I've got those 2 calculators ready.
Okay, yeah, because that's pretty much what we are gonna do now.
Yeah. Okay, here we go. Diane earned a score of 160 on the quantitative portion of the GRE. What is the Z-score corresponding to Diane's score? Well, that one, literally, we don't even need... I'll come back here later. Literally, we can just plug in. Just to confirm the score formula, because I realize I've been using this calculator the whole time. What is the Z-score formula again?
No, that's for the lesson that we used for the last week. This one, we use another, like...
Oh, right, that weird one.
Yeah.
Oh, right, and that's pretty much the same. Thank you. Okay.
Mm-hmm.
All right, so first things first. Clear. 160
I don't
minus...
see a population number, though.
What?
It says that we have the mean, and then we have the standard deviation.
My daughter.
And then we have the score of... Hey, daughter.
Wait, hold on. Don't let her leave. Don't let her leave. Let me see. Screenception. Hold on. Screenception. I'm ready. Is she gone?
Yeah, she left.
Oh, we just all got screenception for no reason.
Just started walking.
Okay, can we use the score as a... I don't know.
Well, but the score is X, not N.
And then...
N is the number of, the population number.
Yeah. Okay, so let's do it the traditional Z-score way, okay? And let's see what happens there. Because remember, Isaac knows all the answers, so if it's wrong, then
tell us.
we can no-scope my face.
I got 1.045.
1.045.
Mm-hmm.
Yeah, that's right.
Yep, so it was traditional Z-score, guys. So we have 1.045. And then, what is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE? We just take that over here, right? 1.045. Well, that fails 1.045. And we just look at this, right? So it would be 0.148.
Yes.
Mm-hmm.
Okay. 0.148. Saving.
Okay, is by any chance 1.045?
Mm-mm.
No, it's not.
Oh, wait. Did you say 6?
No. I mean the answer. It's
For question 6, it's 1.045.
Okay, thank you.
Yeah.
I
Question
was
7
trying
is...
to find that one.
No, you're good. That's why I was like, we're on 7. That sounds like the previous answer.
Sorry.
We just finished 7.
See, I was still in 7, but I'm now
No,
in
you're
6, in 7. Let's go.
Okay. And as you can see on my screen, you guys can see that, right?
Mm-hmm.
Okay, yeah. That's what we got for 7, and Isaac confirmed.
Okay, good.
All right, so question 8 is a random sample of 5 students were selected to take the GRE. Their scores are bleh. what is the z-score corresponding to the sample mean of these student scores? Now we need to get the mean first, right? And that's this special formula we have, which is like 1 times 160 plus 2 times 175 plus 3 times 163 plus 4 times 49.
To find the mean is so annoying sometimes.
5 times 153. Enter. That's that, and then it's divided by
5.
that number minus 1. So 4. Your heavens. That's not right.
Mm-mm.
Me, it's 590.
we just
The
need-
average is 590. You're all failing.
No, so one day you get the mean. I think that we have to use the same formula, the z-score. And yeah.
Use the z-score to get the mean?
No,
The problem is we don't know what the z-score is or the mean. Oh, wait, for the next 4 questions. Go back up.
What I did to get the, I added up all of those numbers.
Uh-huh.
And then I divided by 5 because it's 5 of them.
5.
Yeah, so when you add all of those up, it's 800 divided by 5.
Was it? Okay, and this was the right answer way, right?
Correct.
Okay. 5, and that takes us down to what?
So
I got
mean,
160 for the mean.
Yeah, 60, yeah.
So what is the answer?
160 is our mean. So now what we can do is we can plug in everything else from up here. So we've got 160, 150.8, 1.88. Wait.
160 is the mean, not the variable or value, whatever.
Oh. Well, then what's x?
It's not on the top?
Well, no, we have the quantifiable, like the sample mean for everything. And then we have this mean down here. And it's not.
You change the mean, and then you use the same standard deviation. And I don't know about the population.
Yeah, I'm looking for the experimental result of x. What do we put as x?
I'm trying to remember why, but for x, I put 160.
And you put the mean as 160?
Maybe,
so
maybe we have to take away.
And just to confirm, again? Isaac, the answer isn't 1.04545?
No.
Okay.
No.
You have the wrong mean inputted.
Because if we do 160, it takes us to 0.
But I think that we have to take the 150.8 and subtract the one that you get. Again, do you remember?
Okay.
When we subtract on the top of the formula, I think that we have to do that one.
Try that one. So our sample mean is the x, so that's 160 minus 150.8. Enter. That's what we got. And then n was what?
We don't have an n.
Don't have an n.
Oh, wait. A random sample of 5 students.
5. Okay. So we need the square root of 5. 2.236 divided by the standard deviation. What was the standard deviation?
8.8.
8.8.
8.8? Divided by 2.36. 8.8 divided by 2.236. 8.8 divided by 2.236. And that gives us 3.935. So divide that 9.2 by 3.935. We get 2.377. Or 2.337.
Yeah, and then when you round it, it's 2.338. And that's the right answer.
That is Isaac.
Yes, it
You
is.
get
Yeah.
it.
2.3.
You rock it.
Yeah. Thanks to you, Estrella. Let's see. What is the probability that 5 randomly selected students will have a mean score that is far greater than the mean achieved by the students in the previous problem? Oh, goodness.
Why don't we use the probability applet?
Yeah. So we need to get the z-score for what we had. And this is the z-score, right? 2.388?
Yes.
Yeah.
Okay.
So just put that on the thing and it will give you an answer. And then you will tell me that one because I don't have it. And I'm so
You're good.
lazy to go
Let's see.
over.
Let's see. We'll have a mean score that is greater. Okay, so according to the normal probability applet, that's 0.0097. Isaac?
That's what I have.
I have a 0.0098.
98?
Yeah, because
Yeah, because you rounded. Oh,
yeah.
why?
Well, it's because you round your answer to 4 decimal places.
Oh. Well, because see,
Or-
the normal probability applet says 0.097, but
Yeah.
Oh, really?
yeah. Like if I look at it right now, says
That's what it comes out as.
yeah, but the correct answer is 0.0098.
Yes, that's what I have.
Okay, and if that's correct, maybe it just didn't round. It just cut it off after 4. I don't know.
Maybe both answers are right, depending on how you figured it out.
Maybe.
I'm going to go with 98, though.
Seriously. Use the following information to answer the next 5 questions. Suppose the mean GPA of students is 3.5, standard deviation 0.7. It is well known that this distribution is left skewed. Of course. A random sample of 81 students is drawn. What is the shape of the sampling distribution when a variable x, which represents the sample mean of 81 students are selected? That's normal, right? Like approximately normal, because 81 is like a large number.
Well, what are we?
Because I think, yeah, because central limit theorem said like if the sample is so high, it's normal, right? I think so. Yeah, approximately
Yeah.
normal. Isaac?
If it's above 30, then it would pretty much be considered normal.
Okay, sorry. I am on the question 9. What was the answer for that one?
0.0098.
9. But say that we. Oh yeah. Sorry, I was sleepy.
You're fine.
And then we're on the next question, which mean is 3.5, standard deviation is 0.7, and the distribution is left skewed. We have a random sample of n equals 81. And the first question was, what is the shape? And according to the central limit theorem, it's normal. And we confirmed with Isaac, and that was correct.
Okay,
Yeah.
good.
What is the mean of the distribution of the sample means for all possible samples of size 81 that could be drawn from the parent population? Because that's not the z-score one. I can't access my notes.
I think that you can.
Well, because I'm logged into a different email, so I can't touch my original. I can go to the note, like the textbook that we're reading from, and access. Let's see. Okay, what's the question say? What is the mean of the distribution? So we're not looking for z-score. Yeah, so can we have someone look up a formula for that? Because all I'm seeing in chapter 7 is like sampling distributions. Mean of the random variable is u. Deviation. Yeah, because it's showing standard deviation how to get z-score.
So for that one, we actually do not need a formula.
Really?
Yeah, because it's only asking for the mean of the distribution of the sample means.
Oh my gosh, that's
Which-
the same thing, isn't it?
Which we get that information at the beginning, which is 3.5.
I'm going to bed. Good night.
That's okay. I was just like you, trying to figure
Done.
out how to solve it. You know,
Distribution
like this
means,
have to be
sample
complicated.
means, same thing. I remember that now. Thank you, Isaac. What
No
is
problem.
Isaac, you're the smart one.
Sorry?
I said you're the smart one.
Oh, no.
We
No,
take
by no
turns.
I just
We
wanted-
do. We take turns. It's Isaac's turn today. All right, let's see. What's the standard deviation of the distribution of the sample means? That's the same, isn't it? It's
Yeah.
the 0.7
0.7,
or
yeah.
0.7?
0.078.
What?
Yes.
Is it 0.7 or 0.78?
78
it's,
because you have to round it to 3 decimals, I think.
Yeah.
Because if you look up...
Yeah.
0.078.
What?
0.078.
Oh, okay. Then I had it wrong. Standard deviation of distribution of sample means. So, because I like solving things, let's go. It's 81's our n, right? Not our x. So 3.5.
Repeat that again. Sorry, I was sleeping.
You're good. So, in order to get this,
You take
we need
away
to
from the 3.5. You take away the 3.3, and
what's
then
3.3?
isn't the question in the 13? Sorry, are we in that one or we already passed it?
I'm not at
She's in
13. I'm at 12. I'm trying to solve 12.
Oh, okay. Sorry. See, I'm sleepy.
Because it was, what is the standard deviation of the distribution of the sample means? And I was like, well, that's 0.7, right?
Well,
But then I was told, no, it's 0.078.
because you have to do use the because they say that you have to put it in 3 decimals. So
Yeah, well, the thing for that one, Kelsey, so you take the 0.7 over the square root of 81.
Oh, right.
And then that's how you get the 0.078.
0.7 divided by 9. Oh, dear heavens.
I think that we need to do this meeting for the exam,
That would be nice.
and that way we just have to figure it out. Hey,
Okay,
who have this
13.
one right? Okay, let's go, and then everyone will be having A.
Probability of mean GPA for 81 will be less than 3.33. So we need to get the z-score on that one, right? So we can plug it in and get that answer. So, all right. So we have 0.78 as the bottom already, right? Because it's just the same thing as 0.7 divided by the square root of 81, which is 9. So that's 0.78.
Yes.
Okay, and then what's our n?
81.
It's 81 minus the mean of 3.5.
Mm-hmm.
Divided by 0.078 will get us... That's not right.
Well, it has
So,
3.3 in the question. Did you see
yeah,
that?
so for that one, I plugged it in
3.3 minus 3.5. There we go.
3.5.
Yeah.
Yeah, over.
Divided by 0.078.
Yes.
Negative 2.564. Yeah, because the minute I took it down, I was like, that's not right. Negative 2. Negative 2.564. Enter. And it will be less than 3.3, right?
Yeah.
So that's 0.01. Oh.
No, I actually get
Hold on. There we go.
0.005. Okay, now we are good.
Ah! No, because I had both sides clicked, so it's 0.052, right? Or 0.05?
Yeah, you get the right one now.
Okay. All right, that's correct, Isaac.
What you guys get?
0.005.
Yes, we're 13, right?
Yeah, and 14 is the same answer, right?
No,
What?
because for that one,
Because his
put
one
it-
is great.
for that
He's
one you
graded.
shade the middle and the left.
Oh, right. We discussed this one, and I didn't like it. Okay, so 0.9948. Or 995.
Yes.
And then 15. Oh, my goodness. The United States Coast Guard assumes the mean weight of passengers in commercial boats is about 185 pounds. The previous value was lower, but raised after a tragic boating accident. Oh, my goodness. Standard deviation of passengers' weights 26.7. Sample 48. Sample mean 177.6. Okay, so that's the actual mean. Find probability that random sample of passengers will have weight that is as extreme or more extreme, either above or below the mean that was observed in this sample. Isn't that just one?
The United States Coast Guard assumed that the
Or 100%? I mean, that doesn't sound
No.
right.
The previous value was lower, but was raised after the tragic.
So, as extreme or more extreme than was observed in this sample. So does that just want the two ends then?
So for this one, I got the answer, but I didn't write all of my work down, so I don't know exactly if I got it.
No, I think that you just use the formula. So you have the mean, and you have the standard deviation, and you have the population, and
the value.
Yeah, that's what I'm saying. Like, do we just plug in the z-score and we're filling in the two right sides? So let's see. X is 48. Mean value was 177.6.
Yes.
Standard deviation was 26.7.
I don't know, because I mean we have two means.
Well,
So I think
they originally assumed that mean was 185, but then they determined it to be 177.6.
Mm-hmm.
So I think that's our actual mean. The first one I think is just to scare us and throw us off.
okay, so let's go and try with that one. If we get something, then we check with Isaac.
Yeah, so I got negative 4.853. So let's go here. Negative 4.853. That's just way off the scale.
Do you think maybe we use the other score formula?
Oh, yeah. Yes. I keep falling back on you. Go away. Okay. What about two calculators again, Kelsey? Okay. So, square root of n, which is the sample of 48, right? Oh,
Yes.
Q means. I get it now. Australia. You're not crazy. I'm crazy.
Thank you.
Okay, so square root of 48. So 48 square root is that, whatever that is. And then our standard deviation is some scary number, like 26.7, right?
Yes.
Yeah.
26.7 divided by, and let's go 6.928. Keep that number for a later time. And then we have the sample means, which is x minus the other mean. So 177.6 minus 185. Enter is 7.4. Divided by 3.853. Gives us negative 1.92. All right, and on either extremes, if we're saying as extreme or more so.
Yeah, and because we have to round to 3 decimals, then it's gonna be 0.055.
Isaac?
0.055. That's correct, yes.
Yes!
Okay.
Yeah. It's 0.055.
Yes.
Yeah, good job guys, because I had forgotten how I got that.
That was honestly thanks to us typing in the z-score in the first one and being like, that was wrong in every way. And then Caitlin mentioning again, maybe we should do the other z-score. And it was like 2 means. Oh my goodness.
And we get all right.
We did.
Yeah.
Let's see. There is that. Okay. Close out of all of this. Okay. So that is all the meeting that we needed to do. Hold on. I'll stop screenception. Hi, guys. Oh, yeah, and Estrella hides her cam. That makes me feel better. It's probably been off the whole time. It was just funny because I just noticed it. And so it was like, hi, guys. No, turn off the cam. No looking.
No, it's just because I always use my phone the entire day. And then every time that we do the meeting, I am running out of battery. And then I can use my camera.
You're totally good. Okay, so I will post this tonight with the names of everyone except Isaac. And then are we still on to meet Tuesday at 9:40?
Yes.
Yeah.
Caitlin?
Can you believe that I didn't do the homework on the previous week for the lesson 4 and 5? I didn't do the test, the homework. I don't know. I don't remember.
Oh, that's surprising.
Yeah, and it was like, what the heck? I don't have anything on the score. And well, okay, my bad.
That makes sense. All right, we've almost been here for an hour.
Oh yeah,
we committed.
but we made it.
Watch our live stream, Brother Liam. We promise it's worth it.
We're all falling asleep halfway through.
Yeah.
Except for Kelsey, but that's just because she's trying to figure it out because she's so lost and confused that she's just like, what's happening?
Okay, well, I have to wake up tomorrow at 4 a.m. So.
Oh, I was like, you have to wake up? I do too. Okay, so yeah, Tuesday, 9:40, we'll be going over lesson 8.
Okay.
Yes.
I almost did this, but I did this. I'm getting proud. I'm learning how to count, guys.
Great for you. Okay, see you Tuesday.
Tuesday, 9:40. Take care.
You too.
Yeah.
Bye-bye.
Bye, guys.
Bye. Isaac, are you still here? Just gonna eject you, buddy. Okay, bye.